Question. What is PRPC in Pega and what are its benefits? Answer. PRPC, or Pega Rules Process Commander, is the core component of the Pega platform. It is a business process management (BPM) tool that provides a framework for developing applications. The key benefits of PRPC are its capabilities for rapid application development and deployment, its rule-based architecture that promotes reuse and modularity, and its ability to encapsulate complex business logic in an easily managed format. Question. Could you explain activities in Pega and the best practices for using them? Answer. Activities in Pega are sequences of steps that perform a specific action or task, much like methods in object-oriented programming. They are one of the key building blocks for implementing business logic in Pega. Some best practices for using activities include: use activities only for procedural processing and data manipulation, avoid using activities for UI logic, avoid excessive use of Java steps, use the correct method for each step, and always document what each activity and step does. Question. Can you differentiate between a decision table and decision tree in Pega? Answer. Both decision tables and decision trees in Pega are used to encapsulate and implement decision logic. A decision table uses a tabular format to map inputs to outputs, suitable for situations where there are clearly defined sets of input-output pairs. A decision tree, on the other hand, uses a tree-like model of decisions, ideal for handling more complex, branching decision logic. Question. What is rule resolution in Pega and why is it beneficial? Answer. Rule resolution in Pega is the process the system uses to find the best or most appropriate rule instance to use at runtime, considering factors like the class hierarchy, rule set, date range, and circumstance. The benefit of rule resolution is that it allows for rule reuse and versioning, leading to more efficient development and easier maintenance of applications. Question. Could you define a declarative rule in Pega? Answer. A declarative rule in Pega represents a form of business rule that is evaluated automatically by the system when certain conditions are met. They are essentially if-then logic statements that are used to calculate values, define constraints, and enforce relationships between properties. Examples of declarative rules include expressions, constraints, decision tables, decision trees, and so on. Declarative rules help to automate business logic without requiring explicit triggering or sequencing in a process or activity. Question. What is an agent in Pega and how does it function? Answer. An agent in Pega is a background process that performs automated tasks on a schedule or based on certain conditions. It functions by waking up at scheduled intervals, checking if there are any tasks that meet the criteria defined in the agent's activity, and then executing those tasks. Examples of tasks an agent might handle include sending reminder emails, purging old data, or executing batch processes. Question. Can you explain data pages in Pega? Answer. Data pages in Pega are used to load and hold data that's used in an application. They provide a layer of abstraction between the application's data and its source, allowing you to change the data source without affecting the rest of the application. Data pages can be scoped to the requester or a specific thread, and they can load data on startup or on demand. They are a critical component of Pega's data management capabilities, offering efficient, declarative data access. Question. Can you explain case management in Pega and its benefits? Answer. Case management in Pega is a systematic approach to manage the lifecycle of a business process, also referred to as a case. It provides an organized structure to define stages, steps, and processes that need to be completed for the successful resolution of a case. The benefits of using case management in Pega include the following. Enhanced visibility. It provides a holistic view of the entire case lifecycle, enabling stakeholders to monitor progress and make informed decisions. Consistency. By standardizing processes, it ensures consistency across multiple instances of a case. Collaboration. It enables different stakeholders to work together effectively, as each one has a clear understanding of their role in the process. Efficiency. Automated processes and decision-making capabilities help in faster resolution of cases and increased productivity. Question. What does locking mean in Pega, and can you describe the different types? Answer. Locking in Pega refers to the mechanism to prevent simultaneous updates to a case by multiple operators. Locking prevents data conflicts and ensures data integrity. There are two types of locks in Pega. Optimistic locking. This allows multiple users to open a case, but only the first one to save the changes can do so successfully. Others will receive a notification that the case has been updated. Pessimistic locking. This prevents other users from opening a case when one user is working on it. It guarantees that only one user can make updates at a given time. Question. What is an exposed property in Pega? Answer. An exposed property in Pega is a property that can be directly accessed and used by the database for sorting, retrieving, or filtering data. By default, not all properties are exposed. Exposing a property allows it to be included in a database index, improving the performance of database operations that involve that property. Question. What is declare index in Pega, and how would you set it up? Answer. Declare index in Pega is a rule that creates and maintains indexes for instances of one class and properties of instances of another class. These indexes are used to speed up database queries. To set up declare index, follow these steps. Create a new declare index rule and specify the source class. Define the properties of the source class that will be indexed. Specify the class of the index instances and map the properties of the source class to the properties of the index class. Question. How would you measure your application's performance in Pega? Answer. Pega provides several tools to measure application performance. The Pega Predictive Diagnostic Cloud, PDC, can be used to monitor the health of your application in real time. It provides insights about system health, case processing, and team performance. Alerts and logs in the Pega Rules Log Analyzer, PLA, tool can also be analyzed to measure performance. PAL, Performance Analyzer, is another tool that helps developers understand the resources consumed by their actions. Question. Could you explain the concepts of work list and work basket in Pega? Answer. Work list and work basket are two key concepts in Pega. A work list is a personalized list of assignments that belong to an individual operator. It represents the tasks that are specifically allocated to a user. A work basket, on the other hand, is a shared pool of work. It contains assignments that are not assigned to a specific individual, but rather to a team or a group of operators. Users from the same team can pick tasks from the work basket. Question. What is declare trigger in Pega, and how would you create one? Answer. A declare trigger in Pega is a rule that defines an automatic, asynchronous response to changes in a database instance. It allows actions to be performed whenever instances are created, updated, or deleted. To create a declare trigger. Create a new declare trigger rule, specifying the applies to class and the trigger activity to be performed. Select the event that will fire the trigger. This could be save, delete, or save as a new copy, corresponding to instance creation, deletion, and modification, respectively. Specify the condition under which the trigger will fire. This could be an always condition or a when condition based on a when rule. Question. Can you explain forward chaining and backward chaining in Pega, providing examples? Answer. Forward chaining and backward chaining are inference techniques used in Pega's declarative processing. Forward chaining. It is a data-driven approach, where a change in a property value triggers the recalculation of other properties that depend on it. For example, if you have a property total that sums price and tax, a change in either price or tax would automatically update total. Backward chaining. It is a goal-driven approach, where a property value is calculated only when it is needed. In the above example, total would be calculated only when it's accessed, not when price or tax changes. Pega Knowledge Base. Knowledge matters. Like, share, subscribe, and comment.